Hello everyone, welcome to the yet another video of measurement and instrumentation. So as of now we are discussing about the types of instruments. So in previous class we have discussed about the permanent magnet moving coil instruments. In this video we are going to discuss about another type of moving coil instrument, which is the EDM type instruments, which is the electrodynamometer type. So electrodynamometer type moving coil instruments are a modification of PMMC instrument. The only modification is that in PMMC you are having a permanent magnet as the field, but here it is replaced by two fixed coils, just like what you have in a motor. So a dynamometer type moving coil instruments have a permanent magnet being replaced by an electromagnet. The principle of working is very same as that of the PMMC, which is the electromagnetic induction. That is, whenever a current carrying conductor is placed in a magnetic field, a force is being exerted by the conductor. In this case, since the fixed coil produces a magnetic field, the moving coil carries the current to be measured and is suspended in the magnetic field. Hence, it experiences a torque. The moving coil then rotates through an angle proportional to the current flowing through the moving coil. As the pointer is attached to the moving coil, we get the pointer deflection proportional to the current measured. So let's see the diagram for dynamometer type moving coil. As I already told, the PMMC and dynamometer type instruments are very similar, except with the fact that the fixed coils here are replaced by a permanent magnet in PMMC, whereas dynamometer we have two fixed coils which are being excited separately with a current IF, and the rest are very similar to that of a PMMC. So we have a moving coil and also a spindle to which a pointer is attached, and it has a counterweight which is called the balancing weight, and which produces the controlling torque. And these are the things which are very common for PMMC. So the only difference here is the fixed coils, which is F1 and F2. So let's see the construction. So here F1 F2 are two identical circular air cooled coils. They are connected in series and are parallel to, these coils are parallel to each other. They produce a uniform magnetic field, and the moving coil is denoted by M, which is lightweight, and it lies in the magnetic field produced by the fixed coils F1 and F2, and it is supported by a spindle and a jewel bearing, and two control springs wound in opposite directions are used as leads to pass current in moving coil, which is given here. Now let's see what are the advantages of dynamometer type instruments. The use of iron is being avoided here, hence it is free from hysteresis and eddy current loss. Unlike PMMC, this dynamometer type instruments are useful for measuring both AC and DC, and it provides high degree of accuracy also. And an important advantage is that it can be used as transfer instrument. That is, it is often used as standard instrument for calibrating ammeter and voltmeters. Now let's see what are the disadvantages of using a dynamometer type instruments. Here the disadvantage is that the scale is non-linear, and because for every current measured the deflection torque is not directly proportional, and also the torque to weight ratio is small, and since we are using fixed coils, external electromagnets, these instruments are expensive compared to PMMC, and also these instruments have low sensitivity, and the last limitation is that the shielding should be provided to avoid effect of stray magnetic field. Since we are using electromagnets, there is a possibility for stray magnetic field to be within the instrument even when the even when the system is at rest condition. So proper shielding has to be provided so as to avoid the stray magnetic field effect. So these are the main points that are need to be discussed about the dynamometer type moving coil instruments, which is the EDM type instruments. Hope you understand the topic. We will discuss the other types in the upcoming videos. Thank you.